Hello and welcome to our presentation of the Blaze ecosystem, where we will use Python and big data. Throughout this presentation we will go through an introduction to the Blaze ecosystem and the Blaze project, what backends does Blaze work with, then we'll show a simple example to introduce Blaze expressions, then we will explain why it is useful for big data and show an example with some big data, and finally we'll make a conclusion.
So, when talking about the Blaze ecosystem, one can refer to it as both a library and an ecosystem. The ecosystem consists of different projects that provide each rich and efficient data analytics. This is where Blaze augments these projects with a uniform and easy to understand interface. The Blaze library provides Python users high-level access to efficient computation on inconveniently large data sets, even out-of-memory computations. This we will go in depth with later on. The Blaze project. With Blaze you are able to use expressions for queries on either a database or big data files. This allows Blaze to operate on different backends with the same syntax, since Blaze will handle the translation of the expression to the query. Blaze uses a NumPy pandas-like syntax, and it provides Python users with a familiar interface. Furthermore, you are able to use Blaze queries across different data systems, ranging from a CSV file to a distributed database or other big data files. Blaze will only communicate with the database when it is necessary, while it is also able to analyze and optimize queries to improve the interactive experience. To summarize, Blaze can be used as a high-level user interface for databases and computing systems. It uses expressions for calculations and queries. The architecture allows a single Blaze code to run against several computational backends, and that we will also talk more about in the next slide. And in the end, Blaze is able to analyze and optimize queries to improve the interactive experience.
As mentioned earlier, Blaze works on different backends. In this presentation we have decided to show some backends that we have already worked with and know a little bit about. As you can see, they are Pandas, SQL or SQLite, MongoDB or Apache Spark. The diagram on the right shows how the hierarchy is actually working. At the bottom you have the data, which is in either of the four formats showed on the diagram. In the middle you have the engine, which is actually doing the computation, and at the top you have Blaze, which is really not doing any computations, but it is purely expressions that is then sent to the engine that goes further down to the data. In this presentation we will focus mainly on Pandas and SQLite in collaboration with Blaze, and then we will show the two main improvements gained from using Blaze, and that is simplify and make more readable code, and in many cases handle datasets that cannot fit into memory.
Blaze installation is pretty straightforward. You can use pip install Blaze like any other library, and then it should work as it should. We are not going to show this installation, but we will rather show an example of how the code can run within Python, and we will use an IDE called PyCharm. So now we are within PyCharm, and we want to show this small example of accounts in like a database bank system, and we are going to use the two functions from the Blaze library called table symbol and compute. Table symbol is used to identify the table with the different key values called ID, name and amount, which is these values in the list, and the whole table is called accounts. Furthermore, we then can use this expression called deadbeats, and that is actually the Blaze expression we were talking about in the previous slides, where we want to look up all the accounts, all the names of the accounts that have a negative balance. So that would say Bob and Edit. We then use compute to do this expression on this table, and hopefully it will print out the right result. And it does. Hooray!
So now we want to show an example we have actually worked with before from week 3, where we had the IMDb movie database. If you recall, the first exercise was to extract the top 5 movies. The first thing we have done is create the pandas table again, but we have decided not to show that. Then we use the data function from Blaze, and we give the data function the pandas table as input. The function will then decide itself what data type it converts it to. Then we use this expression to find the top 5 movies, and as you can see, it's actually very similar to pandas expressions. Lastly, we use the compute function as we explained in the example before, where we use the expression and the data. And as you can see, it outputs these 5 movies, and it is actually the same as the result we got in week 3. So it works. We will now talk about big data and out-of-core processing. Out-of-core processing is a concept where your data set is so large that it cannot fit into memory. But Blaze is able to pull chunks of the data into the memory and operate on it. It can do that in sequences, and when it has processed all chunks, it will have to finalize the computation with another operation on the intermediate result. Not only does Blaze support this feature, but it actually does it automatically if you are given a large data file that cannot fit into memory. If your data set is easily separable into chunks in a parallel manner, then the computation may be accelerated by a parallel map. This is actually very neat when you're working with big data. We will now show an example with a very large data table. So our data table consists of the first 4 months of Reddit comments in 2009. That is roughly 3 gigabytes of data in SQLite. You will notice that this data is actually too big to fit into main memory. So now we'll see the strength of Blaze. We will use the IDE PyCharm, and you will see what code we have written. So this is the final example we will show on some big data. And what we have done here is that we have, as explained earlier, taken the first 4 months of some Reddit data and put it into an SQLite database. And the first thing we do is we load the table from the database into this data. And as explained earlier, Blaze will actually figure out that this is too big to fit into the memory, and it will by itself split it into chunks, and you will see that when we actually run the code. Down here we have some expressions, and these are used to calculate what we want to show. The first we do is we count the amount of posts we have in the Reddit database. Then we count the total amount of upvotes. Then we count the amount of posts in the subreddit called soccer. And finally, we have created an expression where we print every author that has gotten a score of more than 1,000. And right here, we just print some outputs. So now we'll actually run the code. And I'll show you that the memory consumption is actually not that large. As you can see here on the Python exe, the memory consumption never breaks 100 megabytes. So it actually works. Blaze is splitting the data into chunks and putting those chunks into the main memory and working on it from there. So this is our output. As you can see, the size of the database is roughly 3 gigabytes. And this is actually what Blaze does. When we write an expression, Blaze will translate it to the backend we're working on, in this case an SQLite database. As you can see, the first
the first expression to count the end post is what we have printed out here, and it gets translated into an SQL query. And then you can see the total number of comments is roughly 4 million. Then we have roughly 15 million number of upvotes, around 400 number of posts in the subreddit. And then we have printed a table here that contains all the authors with a score above 1,000. And that is actually put into a pandas data frame. And we can do that with the Odo library that Blaze has access to. And just finally, we are showing here that Blaze actually works on chunks of data when doing these expressions. So yeah, that was our final example of some big data.
So now you have seen an example of some big data, and we hope you noticed that Blaze uses expressions. These expressions does not improve computation times, but it does give you a powerful tool for making data queries easier and make them more readable. Blaze does, however, have the ability to work very nicely with big data that cannot fit into the main memory, as we have talked about a lot with how Blaze chunks the data. So we hope that you learned a little bit about Blaze, and we would like to thank you for watching our video.